Hello, welcome back to Cracking the Cryptic, and look at this colourful kaleidoscope vision on the screen. This puzzle is Squaring the Squircle by Patrick Repo, and it's just fascinating looking. The colours matter, they have to be there, and in fact you have to be able to distinguish them to solve the puzzle. So I will explain which cells may look similar and are different when I go through the rules, but apologies to the colourblind in case this is too tough for some of you. Anyway, we will have a go at that in a moment, and I'll do the rules. It looks brilliant. Don't forget that on Patreon we've got the unbelievably good Lord of the Rings hunt by Blobs, which is just, it's absolutely beautifully presented. The puzzles are excellent. The reviews are stellar. This is one of the best things we've ever brought you. Do join us on Patreon. There's also loads of other content there at the moment. There's Simon's Thursday crossword explanation, Cryptic, my Solve of the Very Difficult Times Monthly, and my tribute to Richard Rogan as well, which has gone up on the channel. And on Patreon, I did the Friday masterclass in the Cryptics as well. There's also loads of other content, and we do solution videos to last month's reward by Glum Hippo, well worth seeing. Loads of all sorts of good stuff. Do check out Patreon, and our apps. They feature Thermo Sudoku, relevant today. They feature Line Sudoku, Domino Sudoku, and of course Killer Sudoku. So lots of relevant apps, lots of other apps as well. Do check out the link. They are such good value for money, as is our merchandise and SUDOKU PAD. They're all on the links under the video, where the first link is to Squaring the Circle by Patrick Repo. I think it is a debut. Patrick asked us in a second email that if we presented the puzzle, please name me as Patrick Repo because it is my name. That is a very good reason, Patrick, and I like your style. Now, let's do the rules of this. Normal Sudoku rules apply, so at least we're putting 1 to 9 in every row, column, and 3 by 3 box. In each cage, the digits sum to the number given, but these numbers are what? These numbers, so those 6 cells add up to B times B. Now, the next rule says each letter A to H represents a unique integer to be deduced. Now, it uses integer, it doesn't use digit, so I presume that we could go above 9, but obviously integer from its root means a whole number. And they're all different. A to H are all different numbers that they represent. Digits in each colour sum to a perfect square. So if we were to take the yellows, it's those 8 cells, and the contents of those 8 cells, those 8 digits, sum to a perfect square. And this occurs for every colour in the grid. So just as there are 8 yellow cells, there are 8 blue cells. Actually, there are 8 purple cells too. There's 1 single grey in the centre. And then there are these squircles, these sort of squared circles in red and green. And these areas, these colours all add to square numbers, which is fascinating. That is clearly Patrick's USP here. Now, digits on a thermometer. I think all the rest of the rules are what you would call normal, if you recognise the orange line as a palindrome. Digits on a thermometer increase from the bulb to the tip. Digits separated by an X sum to 10. Digits separated by a V sum to 5. Digits separated by a black dot are in a 1 to 2 ratio. And an orange line is a palindrome and reads the same in both directions. So those are the rules. Give it a try because it's fascinating. I don't know. It might be very mathsy. It might be very difficult. It might not be either. I don't know. We're going to find out. Give it a try. I'm going to start. I'm hitting the wrong button. I'm going to start now. Let's get cracking. So I'm going to start with the purple region, which is 8 of the 9 central cells. Now, I'm going to tell you the secret, in case you don't know it yet. The secret that we occasionally allude to on the channel is that every row, column, and box in a Sudoku adds up to the same number, and we know what that total is. It's 45. So Be careful with the secret, but it arises because the numbers 1 to 9 always add up to 45. 9, that is the 9th triangular number. And it's very relevant to this central box where, actually, not only do the purples add up to a square, which has to be a number that is from 1 to 9 less than 45, but actually the grey central digit, which is the only grey cell in the puzzle, has to be a square as well. Now you'll quickly see, if you consider the possible squares 1, 4 and 9 that can be single Sudoku digits, that the one we can deduct and leave a square in purple is the 9. And purple adds up to 36 therefore, and grey adds up to 9. And that is a start to the puzzle, a first digit. Okay, I'm going to go to the thermo because you cannot stop me. Actually, I'm going to do both thermos at the same time. They're both 6 cells long, and you can't stop me putting all the candidates on a 6-cell thermo because it might help at some point, and that is called Goodliffing, after my name, because it is my name. Right, on the V we have 1, 2, 3 or 4 there. I don't think that's necessarily going to be very helpful yet, but it may be at some point. On this other V we've got to have digits less than 5 so they can add up to 5. The X will add up to 10, but that won't particularly help. Right, we're going to have to start considering some cages, unfortunately. Oh no, hang on, let's do this black dot first. Okay, there are some things this can't be. It can't be a 1, 2 pair, because that would make this 3 and 4, and they don't add up to 5. It can't be a 2 and 4 pair, because that would make this 1 and 3, and even they don't add up to 5. So this is either a 4, 8 or a 3, 6 pair, and that will be a virtual pair for 4 and 3 in this row. I mean, it doesn't get me very far, but... well, look at this D by D. Now, obviously, there wasn't a rule given in the rules that said digits can't repeat in cages. That's often said in Killer Sudoku. It couldn't be said here, because as you can see from this cage, we're using 2 full sets of the digits 1 to 9. So obviously there are repeats. That's pretty clear that you can have repeats in cages. Now, actually, we can use these totals. I've just shared with you the secret that applies to each column. 45 in each column. So the first 2 columns here add up to 90. Now, then there's 4 more cells, of which 2 of them add up to 5. So we're up to 95 with this bit. We're going to use these 2 digits to take us to a square number. What is that going to be? Well, I'm sure you know that 10 square is 100, and that's clearly the next square that we come to above 95. The one after that is 11 squared, and that's 121. And we can't get to that because we'd need 26 here, not just 16, which we couldn't even do, but 26 in 2 cells. That's not going to happen. Therefore, we know that this D by D cage adds up to 100, and D is therefore 10. And more than that, since the 2 columns 7 and 8 add up to 90, these add up to 10, and they are the digits 1, 2, 3, 4. This pair adds up to 5, and this pair must add up to 5 as well. But now we get the black dot, and we can't use 1, 2, 3 or 4 again because they've all been used in the box. So this is a 6 or an 8, touching a 3 or a 4 on the black dot. And since we've worked out these 2 add up to 5 by deduction, in either sense of the word deduction, that is a 1 or a 2. And what next? I don't know what next. Okay, what next is the 1-cell cages. Oh, look, I'm sorry, column 9, it's exactly the same deal as the central box. You've got 8 cells out of the 9 cells that add up to 45 in this B times B. Oh, this is better than the central box because we're going to learn what a couple of the letters stand for. But I mean, it's effectively exactly the same calculation as in the central box. This one has to be a square because it's E times E. So again, that's 9. These add up to 36. And now we already learned that D is 10. Now we learn that B is 6 and E is 3. And in the top row, these two are squares as well. I hadn't really clocked at the beginning that every single cage in this puzzle adds up to a square because of the algebra given. Even in this one, which doesn't say letter times the same letter, it says b minus g times b minus g. Well, my algebra is good enough to know that that's giving a square. And these two have to be 1 and 4, the other possible squares that are single digits. That means either a is 1 or b minus g is 1. Now we know that b was 6. So g is either going to give us 1 or 2 when subtracted from 6. So g is 4 or 5. And that means this g times g cage adds up to either 14 or 15. No. 4 squared or 5 squared, 16 or 25. Well, I can't rule either of those out. This b times b cage, oh, this is 36 as well, just like this one, because b is 6. So that's quite a big number for a 6-cell cage in which 5 of the cells need to be different. They could be 98765. Now I'm going to have a look at F, actually. Right, F is obviously not the same as B, which was here, because F is a different letter. So, this area, well, we already know these 8 cells are going to add up to 45 minus either 1 or 4. So they are 41 or 44, plus these 2 is going to take us to a different square. So it could be 49. Could it be 64, 8 squared, the one after 49? And the answer is no, it absolutely couldn't. Because these would have to add up to a minimum of 20 or 23. 2 cells can't do that. Therefore, we're adding up to 49, F is 7. These have to add up to 41. That has to be a 4. Oh, no. Yes, okay, that's fine. These add up to... Okay, hang on. I've done my maths wrong. So let me... Oh, I've got the conflict checker on. Sorry about that. Don't know why. Right, I've got something wrong there. I didn't get wrong that this has to add up to 49. That's right. These 8 cells, we said they're either 41 or 44. Now that means that these 2 cells either add up to 5 or 8. And that depends what these cells at the top are. If those are 41, these add up to 8, and that is a 4, and that's a 1. So then they would add up to 8 without a 1 in. Alternatively, they add up to 5 without a 4 in which case they would be a 2-3 pair. So it's either 2, 3 and a 4 there. Okay, so these 3 cells either add up to 9 or they add up to 5 and that's a 1. So these 3 cells either add up to 9 or 6. Does that help us with the G total, which was either 16 or 25? Yes, it does. I don't think the G total can be 16 anymore, because the maximum these 7 cells could add up to then is 25, and these 2 would add up to 20, and that is just too much for 2 cells. Well, by 3, by a little bit. So now G has to add up to 25. G is 5, B minus G is 1, and 1 times 1 is 1. Therefore, A is 2, and that's a 4. This adds up to 44, and these 2 add up to 5, and they're a 2-3 pair now. And this thing adds up to 25. 36 would be too much. 36. It is too much for 4 cells, that's fine, yeah. I hadn't mentioned this, and I hadn't thought about it. There's a number of reasons why that wouldn't work, one of which is that G can't be the same as B. Anyway, G, we've worked out, adds up to 5. In fact, we've used that there. So this is 25, plus these other 9 is 34. These 2 add up to 11, and they don't include a 4, a 2, and a 3, so they're 5, 6. They're also in this cage, which adds up to 36, so these 4 add up to 25. I don't know what that means. These are 1, 7, 8, and 9. Now, we've had a 1 here, so that affects the thermo a little, all the way up. But we also know that 4, 5, and 6 can't be here by Sudokus. They're all on the thermo. Yeah, I don't know what that does. Oh, this isn't too bad, actually. Now, that is 2 or 3, so this can't be a 2, 3 pair. That has to be a 1, 4 pair, and we get 2 here, 3 here, 6 on the black dot. Now, going up the middle, this can't be a 3. Which big cage do I need to think about next? Or do I need to go to a colour? I'm getting bits of blue here. I'm getting candidates for yellow. Don't know. Well, I don't know. What do you think? Let's try this H by H, because we know that these cells in the B times B add up to 25. So these add up to 20, because I can deduct 25 from 45. Now, these add up to somewhere between 28 and 42 to go on to this 20. So that takes us from towards 48 or 62. Right. Well, I think we know that this isn't going to be a 49 cage, because F is a 49 cage and F is not the same digit as H. So it's got to be a 64 cage, and we said that was worth 20, and this is worth no more than 42. In fact, given that, it can't be as much as 42, but anyway. The cage adds up to 64. And there's 20 there, so these ones add up to 44. And if we compare that with this column, which adds up to 45, that means these two cells add up to 1 more than this one. Now, this one is not 9, 2, or 3. So it's 1, 4, 5, 6, 7, or 8. But these two add up to 1 more than that. That's what we've just worked out. So this can't be a 1. Oh. I didn't really rule much else out, though. And I'm probably now going to forget that those two add up to 1 more than that. But that is one end of a palindrome, so the other end is the same digit. Yeah, this didn't really make good progress, did it? So H wasn't the thing that was worth considering. Although this C is a bit of a hot mess of a cage. We don't actually have that many more clues. I suppose we've got the colours, we've got the thermos. There are more clues. Okay, you're right, there are more. The colours, though. We've done purple, we've done grey. Okay, blue. Of course, now we can repeat. Oh, well, maybe that's the point. Oh, no, hang on. We've worked out that these added up to 44. Oh, I'm going to find out what C is just by default, actually. Those add up to 10. That's 54. And actually, I know the total of the central 3 columns because it's 45 3 times. So that total is 135 minus the 54 that I've just found. Better leave a square. It does. It leaves 81. And C is a 9. So there's nothing really else to discover. I have to make, as long as I make these add up to 25. Oh, well, actually, that's worth thinking about. 987 would leave a 1 here. Basically, there's a relationship between those two and that one, isn't there? If that was 987 and that's a 1, that's 2, 3. So I think these are always 4 more than that cell. The sensible way of working that out is to compare this 36 total with this 45 total. from which we deduct those two, so it's a 40 total. The difference is 4 between 40 and 36, so those are always 4 more than that. But this one, well, these, if they were 2, 3, that's a 1. That would work. If they weren't, there would be at least, oh no, there could be one low digit and one higher one, 2, 7, say. And that would make this a 5. Yeah, okay. There might be a relationship there that's worth pursuing, but it's not obvious to me. I don't want to work on green or yellow yet, and I'm gonna almost have to turn to blue. What are these blues going to add up to? But I mean, I don't know anything about this digit in the right corner or that one really. These two have to be the same. Now, it's too early to work on blue. I don't think it's going to help. I'm not going to do it. Not going to do it. Those add up to 25. These add up to 20. Oh, that 3 is looking at this. Now, there's a 6 there, so that can't be a 6. That means that can't be a 7. Now, we are getting a little bit of clarity on the blue digits, but it's not a lot. 1, 7, 8, 9, 2, 2. One of these is a 2. There's a lot of variability in the blues. I guess that's why they call it the blues. Right. This was the relationship, wasn't it? Those two added up to 1 more than that, which I want to make into a 4, so that can be a 3-2 pair. But it's a bit of a pipe dream. There's no real reason to think that. Now, either this is 3, 6, and that has to be 1, 4. Then this is a 5. Or this is 4, 8. That has to be 2, 3. Oh, that's quite interesting. Then we would get a 7, 9 pair here. Now, did I work out what would get 3, 6, 1, 4? And that's a 5. No, that's not so helpful. These would be from 2, 7, 8, 9. That's a much wider choice. Okay, that doesn't get me anywhere. 2, 3, 6, 1, 4. The other digits in this bottom box are from 5, 7, 8, 9. Now we're beginning to get the semblance of a quintuple there, or sextuple. 3's in one of those cells by Sudoku. Five and 6 have to be on this thermo, and they have to be within those cells. Yeah, in this column, 6 is on it, and it can't be, this can't be a 5, because then 6 wouldn't be on it. Okay, so 5 is definitely in one of those two cells, and therefore not here, and it has to be here. I mean, it's probably not thrilling. Well, it contributes to this 20 total, unsurprisingly. Unsurprisingly, because obviously 5 couldn't be in those cells. If these weren't 987, they might be, say, 983. That's the next highest total they could be. And then that's a 5. Well, that specifically won't work, but then they could be 982. And that's a 6, and that does work, I think. Yeah, okay, we didn't get much further there. So now I am feeling a little bit more stuck than I was before. Okay, and box 1 does look good. We've got 1, 4, 5, and 6 effectively placed. That could be a 2, 3 pair. If that was a 1, then that would be a 1 as well. If that's not a 1, it's part of a 5, 6, 7, 8, 9 quintuple. Is this all going to come back to forcing me to add up the blues or even the reds? Yeah, maybe I should be adding up the reds. Okay. So we know that these on the top row add up to 45 minus a 1 and a 9. So that's 35. Okay, get ready for some arithmetic. These either add up to 35 or 36 in a similar way. So we're up to 70 or 71. Now I kind of have to guess what this cell might be to get an idea of where we're heading. Let's assume it was a 6, the sort of middly digits amongst the ones. Then these add up to 30, and these add up to about 30. Okay, I'm going a bit approximate here. But we were up to, what was it, 71 before, plus 2 lots of 30 is 131. And then these 4 cells have to take us up to a square. We've got a 2, so that's about 133. A 5 or 6, that's about 138. Something around 2 or 3, so about 141. And I bet we're getting to 144. I don't think we have the wherewithal to get up as far as 13 squared, which is 169, a whole 25 more. Even if we changed this by up to 4, that would give us a difference of 8 in the calculation. We could change this by up to 6. That would be 14. No, we are getting to 144 in red. Now, can I do anything with that? It seems quite unlikely, actually. I just need more certainty about what's in the blue cells before I can really do that. Maybe I should consider red and blue added together. Oh, that's getting too complicated. Maybe I need to take the whole grid and subtract from 405, which is the total of a whole Sudoku grid, and like work out the possible sums of squares. But I don't want to do that either, because that is going to be complicated and require pencil and paper. Wow, I'm getting a bit confused then. Right, these two have to add up to 1 more than this. So if that's a 4, they can be 2, 3, and that fits fine with this thing. If that's a 5, they could be 2, 4, and that fits fine with this. If that's a 6, they add up to 7. They would then have to be 3, 4, and that's fine again. 4 has always been this digit there. If that's a 7, these add up to 8. And then they'd have to be 5, 3. And that would impinge on the candidates here. They would be 7, 8, 9. That would be a 5. Weirdly, that would be a 5. I mean, I don't think I'm getting anywhere here. If that was 8, these would add up to 9. I don't think this can ever be an 8. Because if this can't be a 1, yeah, I can rule that out. So this is 3 or 4, and one of these is 3 or 4 as well. But this pair is adding up to somewhere, well, either 9, 8, 7, 6, or 5. So this digit is somewhere between 2 and 5. It can't, 6, I suppose. 2, 3, 4, 5, or 6. If it was a 6, that would be 6, 3 to add up to 9, but that would have another 6 here. So it can't be a 6. It can't be a 4 from the row, obviously. So that is now 2, 3, or 5. If it's a 3, that's a 4, this is a 7. That seems to work okay. I haven't done anything with this thermo yet. Gosh, I don't know what the next stage is. The palindrome is literally only giving an equivalence between those two cells. So it's not actually providing a lot of meat in the puzzle. I can't be meant to do the yellow digits. I might be meant to do the blues, but this one is so potentially anything that this is very difficult. The only digit it can't be, as far as I can see, is 9. 9, 10, 16, 22, 24, 32, 38, plus this. Well, that's interesting. I took the middle values here, 6 on both cells, 12, plus those is 22, plus about 8 there is 30, plus 6 there as the middle value is 36. Well, that's already gets me to a square. If that was the case, this would have to take us up to 49. And it would be 13, which doesn't work. So 36 is not the case. Can we get to 49 at all? 8 and 8, let's go max. 8 and 8 there, 9 and 8 here, I bet we can. 16, 33, 42, 43, that would be a 6. That is quite tricky. Am I meant to use this? It's complicated. It really is. I don't like it. Right, to make the blue cells add up to 36, let's keep those low. 8, 18, 20, 28, 30. Is that what I did before? And this would be a 6. No, it's not what I did before. I worked out how I could get to 49, and again it would be a 6 in the extreme case there. That's very weird. It's just a coincidence, but... oh, I don't know. I don't know what's going on. How do I get this going? If that was 7, 8, 9, this would be a 1. This would be 4, 5, 6. I think then these would have to be 9, 8, 7, 1. And that would be 2, 3. This would be 1, 2, 3, because that's a 1. These would be 2, 3. Then we'd be heading for this total of 49, and these would all get quite big. Oh, that's probably what's happening, but I need some proof somewhere. I'm not sure where I'm meant to be getting it. We've done D times D, we've done B and E and A and G. We know all those totals, we know F. Actually, we know all the cage totals already entirely. Why can't that help a bit more? So it's just the colour totals that we don't know at all. I haven't thought about green or yellow yet. Maybe there's just so much variability in the yellow. Isn't there? There really is. Is there some play between the V and the thermo? Hadn't thought of that. This is 3 or 4. Okay, so for this to be a 2-3 pair, this would be 4 or 5, because it would have to be higher than this 2 or 3, and 2 and 3 would be used up here. Interesting. So if that was a 2-3 pair, this would be 4 or 5, 5 or 6, 6 or 7, 7 or 8, 8 or 9. This would see all of these cells. That's quite interesting. They're all from the high digits, so Now, for this to be 1, 4, it depends which way round it is. For that to be a 4, this whole thermo is forced. 5, 6, 7, 8, 9. This then sees 6, 7, 8, 9. It has to be 5 or 4. Wow, that would give us... So for that to be a 4, this would be a 5. So then this would have to be a 4. That's quite interesting. It does work with that 4. We then have 4s in these positions. One of those two. One of those two. One of these 3, except we know there's that one. And then one of these. Okay, that could all be 4s, but it would be very constraining indeed. For this to be a 5, this pair adds up to 6 and is 2, 4. If that's a 6, I haven't seen this before, that makes that an 8, and that a 4, and that a 3, which is actually the way it would have to be. If that's a 7, these are 5, then 3. And if that's a 8, these are now 5, then 4. And that wouldn't work with this. This can't be 8. That's quite interesting, because that would be 6, that would be 3, and this would meant to be another 6 to add up to one more. Okay, so 8 has been removed from that cell. It's a very minor piece of play, but we've done it. Now, if that was 7, it's very difficult for this to work then. You couldn't put 7, 6, 5, 4 there, or they'd rule out this cell from being anything. So that would be a 3, and this would go 2, 1, and that would be a 4. Oh, I mean, for this to be a 7 would be very tough. In fact, if this is a 6, we're going 6, 5, 4, 3, 2, 1, 4. This would have to be a 7. These are very constraining moments on all of these digits, but there is just enough license for everything to work at the moment, which is wildly frustrating. I hope there isn't something blindingly obvious that can be done. There might be, but maybe a pair of these can be... I need to know more about this digit. That's the trouble. Before I can rule out totals of blue and thus limit this. Oh, goodness, my head is exploding now. I so believe that these are 9, 8, 7. They don't have to be at all, but somehow I've got it rooted that that's what they're going to be. These two add up to one more than that. And the effect on this line is just so massive. Or rather, once I limit this line, this is so limited. 4 there makes this 5, 6, 7, 8, 9. And you've got 5 there. So blue is then seen by 5, 6, 7. Blue would have to be 4 as well, if this is a 4. And that's what I highlighted earlier. It does just work, but it's very, very constraining. But annoyingly, it does just work. And if this is a 3-2 pair, that's already 4 or 5. That's 5 or 6, 6 or 7, 7 or 8, 8 or 9. Again, they will have an impact on this, but not quite enough of one for me to know what it is. Ah, I'm losing my reason here. I really don't want to have to add up these reds. They're so... variable. Maybe I could just deem that obviously the whole puzzle adds up to 405. If I subtract the central box, I've got 360. And that is the sum of red, blue, yellow, and green, which are 4 squares that give me 360. But do I have to do that maths? Maybe I do. Maybe I know enough about what they could add up to that I can do that maths. That's very annoying to think about that. So I believe that blue add up to somewhere between 10, 20, looking at the minimums, 22, 26, 30. Blue is either 36 or 49, and I'm writing those down in front of me. Red, what did we work out? That is 35. That is 35 nearly. Let's go with the minimum blue cells. That would be 36 then. 71. The minimum blue cells leave that being 35 again. 106. And that being 34. So that's 140. I'm going for the maximum red if I'm going for the minimum blue. 140 plus 642 is 152. Well, I can't get to 169 there. So red definitely adds up to 144. Minimum red, let's just check that. There's no way we're going down to 121 because minimum red would be 35. 35 is 70, 28 is 98, and 28 there. We're already over 121. Yeah, so red is definitely 144. A gross number. So, green and yellow between them. Oh, and there's blue to think of. Now I've done blue. Blue is 36 or 49. Red is 144. I've got green and yellow to consider to get to my total of 360. So we could have 144 and 36 is 180 and the same 2 digits again. Is there any other way to do it? 144 and 49 would be 193. I'm sorry about the arithmetic. This was as I feared, actually. I thought we weren't going to get there after a while. Now I think we are. Plus 167. Oh my goodness, you could do that with 144 and 25. I must have done something wrong there. 144 and 49 is 193. Then we've got 167 left. Now that would be another 144 in green and 25 in yellow. That is very plausible. In fact, can yellow add up to 36? Yeah, it definitely can. You could put just big digits. In here, the trouble is yellow is so unconstrained it could add up to 49 at the moment. These digits I've highlighted alone could add up to 34, plus a 9 there, 43. You could easily get to 49. I don't think you can get to 64, but that is really annoying. So I don't think that's telling me anything because there are at least 2 ways you can make these all add up, so I'm on the wrong track. It was worth the little exploration because this might be that kind of math puzzle, but I wasn't getting there. So there's probably Sudoku then that I'm not achieving that needs to be done. Now, it got interesting. Which way round was it? If that was 2, 3, which was very constraining on the thermo. If that was 2, 3, this was 4, 8, and this had to be a 9, 7 pair. And you had 9, 7 here. These would be from 2, 3, 8 in the box. That would be 9 or 7, which would definitely make this cell a 6. And 6, 7, 8, 9 would be a group there. This would have to be 2 or 3. And those two digits, 9 and 7, plus 2 or 3, would have to add up to 1 more than that. Well, this couldn't be a 9 in that case. That's quite interesting. So if that's a 2-3 pair, this has to be a 7. And then this is 2 or 3. And this is 8 or 9. Now, that's interesting. It's not, I think, falsified. But again, if that's 2 or 3, this is 4 or 5, 5 or 6, 6 or 7, 7 or 8, 8 or 9. Now, what's going on to the blue cell? This one that repeats. That's 4 and 8. So it's not 4, it's 5, 6 or 7. 4 or 5 there. These are from 5, 6, 7, 8. So that's a 5, 6, 7, 8 quad in that case. And that would have to be 8, that would have to be 9. You'd get a 9 here. I don't know, I mean, it's possible this does all kinds of things. It's just alive as a possibility. It's frustrating. I don't think that is what happens. Because I'm still wedded to the idea that this is a 2-3 pair and that's a 1. If that's a 2-3, that's a 1-4. That is a 3. So this would have to be the 2. I'm sure this is going to be the 4, so that can be the 1 and give the thermo some freedom. But this is just me speculating. That is not me solving the puzzle. Sometimes a speculation can lead you down the path of righteousness in these, but not always. Oh, goodness gracious. What are we meant to do here, Patrick? This is very, very hard to work a way through. And it was interesting because it was relatively straightforward to get started in this, but now it's tough. It's awfully tough. Don't like this repeating digits in cages malarkey, because that is just confusing as heck. Two, 3, 9, 1, 4. This is by Sudoku 5, 6, 7 or 8. Which is a reasonably restricted set and is definitely in play on this thermo. This thermo is so weird. I mean, it's so odd that if that became a 4, this would be a 4, but it does happen, and it would actually keep alive. Now, I haven't thought about this much. Is that meant to be thought about? This can't be 1, 9, because there's a 9 in the box. This cell can't be 2 or 3. Actually, it can't be 4 because that can't be 6. So this is a big digit, 6, 7 or 8, and that is 1, 2 or 3. I mean, I haven't known this before. It's worth having a little look at, maybe. Although I don't see where we're really going. This these cells haven't impinged on anything else. Doesn't quite give me a 5, 6, 7, 8 set there, which would make this 1 or 4, and I don't think that would help. Ah, goodness. Now, if that was a 5, this would have to be 5 down here, and that would be 5. What does that do? Not a lot. And I'm so close to a useful quad or quintuple in this row. Where do 1, 3, and 4 go in the row? 3 and 4, well, 3 is in one of those cells, 4 is in one of those 3. But 1 could extend into that cell. This digit, it's got a lot of possible cells, a lot of candidates. I mean, that's an awful lot of candidates. Even if I was trying to add up all the red cells, that's tough to use. I'm not surely meant to add up the greens. It's something I haven't really tried to do because it just looks far, far too open-ended. It does. I'm not going to be drawn into that. It would be a huge summation of digits. It's something in row 2. It is. If that was a 6, this would have to be a 4-8 pair, and that would have to be a 2-3 pair. Oh, that's really interesting. I haven't seen this before. If that's a 6, this is a 4-8 pair, that's a 2-3 pair. Because that's a 5, this is a 4. And now this is a 7, definite 7. And it's there as well. And this is a 4. So then these have to go 5, 6, 8. Now something must break there, surely. This is absolutely fixed. If this is a 6, we get so many digits going on. We get 4, 8, a 2, 3 pair. 4 there, 5, 7, 8, no, 5, 6, 8 it was here. Seven here, but also these would have to add up to 3, 4 as a result of 7 there. No, what is it? They'd have to add up to 8. Oh, that doesn't work. Hang on. If that was a 6, that's what I'm starting from. This doesn't work. Okay, got it. Wow, that's hard. Right. I hope this helps. We will see. Maybe it doesn't, but I've proved this isn't a 6, because that would be a 4-8 pair. That would be a 2-3 pair. This now is 4 or 5, but we know that's 5. So that's a 5-4 pair. This is seeing that 5-4 pair and the 6 in the cell above. No, it's not a 6 in the cell above. If that's a 6, this is an 8 in the cell above. Oh, maybe I haven't got it. This could then be a 6 with those two adding up to 7 and being 3 and 4. Oh, well, that's depressing because I thought I had it. If this is a 6, we've got 4, 8 here, 2, 3 here, 4 there, 5 here. This can now be a 6 because 7 won't work. And that can be a 3. 3, 4, 8, 6 we would have there. I mean, I suppose we now know from that. Do we? No, we don't know from that 3 is in one of these cells, because it all started with this being a 6. Oh, this got crazy in a hurry, this puzzle. And I really meant to do the holistic maths, because that's not something I want to be doing. And I mean, I worked out, didn't I, that there were 2 ways of doing it at least? 36, 144, 36 and 144. So both blue and yellow being 36, both red and green being 144 adds up to 180. 180 times 2 equals 360. But also 144, 49, 25 and 144. But I don't understand, because 49 and 25 don't add up to 36 and 36. So I've done something wrong in the maths there. 49 and 144 is 193. Plus 167 is 144 and 25. I'm really confusing myself a bit with that maths. It just doesn't work. I have to reconcile this. 49 and 144 is 193. Then I have 167 left to get to 360. What? And that's 144 and 25. But how can 144 plus 144 plus 49 plus 25 equal 160 at the same time as 144 plus 144 plus 36 plus 36? It can't. 872. I'm definitely doing something wrong. Yes, 144 and 25 do not add up to 167. They add up to 169. That's what I'm doing wrong. So that is not a way around the solution. So, I now believe that we have to do it 36 plus 144 plus 36 plus 144. So the blues have to add up to 36, and the yellows do too. The greens are 144 and the reds are 144. The big squircles are 144. So the blues have to be 36. So we worked out the minimum, 8, 10, 20, 28. 2 there is 30, and 6 is the maximum cell here. Now, where could we lose degrees of freedom? Well, we could reduce that 6 to, well, down to 1. That's 5 degrees of freedom. So we couldn't make this a 7, because then we won't get within 36. So 7 has gone from that possibility. Now that is good, because now this can't be 6. If that's a 6, that's a 5. This is 8, 4. This is a 2, 3 pair. That's a 4. That has to be a 3. No, this does work, doesn't it? That's a 4. This is 6. So these are 5, 7, 8. And that's 9. So it still works, even with that being a 6. I thought we were going to get somewhere finally. 2, 3, 1, 4. I'm looking at the central column. I'm not getting anything from it. Blue has to add up to 36. So if that was a 6, we'd be on 18, 28, 30. Well, no, we wouldn't be on 18. We'd be on 12, 22, 24. Let's make that an 8, 32. And that a 2. That's the only way, well, no, that could be 8 or 9, but that would have to be a 2. And this would be 1 or 2. That's the only way to get there if this was a 6. I mean, there'd be quite a lot of other things forced, actually. Because if that was a 6, that's an 8, and this has to be a 7. And that's a 5. Like, you get everything forced. That would be really helpful. Now, if that's a 2, which is what happens if we try and make this a 6, what happens to red then? We've got 35. Let's keep it as low as we can. So 35 there is 70. Plus 11 from 45 is 34, is 104. And again, 34. 138. 143, 145, we're bust. We can't do red if that's a 2. So that's not a 2. Red has to be 144. And that means this isn't a 6. And now we've got something going on, surely. If that's a 6, this is 4, 8. And that's a 5. And this sees 4 and 5. 4 there and 5 there. And that's impossible. So that's not a 6. That's a 5. And it's because of the big maths on red and blue. This is crazy times we're living in. So that gets me the 5 and 6. Now, this is what I've worried about the whole time. That doesn't actually resolve this thing. So let's think again about these being a 5, but we have to keep blue down to 36. 10, 20, 22. Let's go with the minimum here. 8, 5, and a 1. That's how it would have to work. But if that's 8 and 5, what's happening to red? We've got 13 is 32. 31, that's 63. 35 and 35. That's 70 and 63 is 133, 138, 140. These two would have to add to 4. Now, they can just do that. But this one would have to be a 1. And what was this was to get red done at all, wasn't it? Yeah, this is the maximum red. This is it. This is it. This is how we keep red down to 144. We maximize these things. Oh no, maybe I didn't use maximum. If we maximize those, actually this might be much easier than I thought, annoyingly. I mean, easier for red to stay alive rather than for us to solve the puzzle. If those are the max, 9 and 8 there, then we've got 28, 28, 35 and 35, which is 63 times 2 is 126. 131, 133, these just have to add up to 11. That's it. We're going to be making blues at the bottom pretty big. Oh, it was all based on these being 5s, was it? 10, 20, 22. Oh, that was the problem. Then, oh, I see. For these to be, we can't keep those that big because these are worth something. If these are 5s, this is it. 10, I was right. 10, 20, 22. We have to keep those down to being 8 and 5. What I should just do, actually, is multiply the perimeters. 45 times 4 is 180. Subtracting these numbers twice, the corner numbers, which I'm assuming 8 and 5 down here to allow these to be, those to be 5s. I'm assuming 8 and 5 there, 9 and 1 here is 23. We subtract 46 from 180 and we've got 132. And then these can add up to 12 to make 144. Which is 7 there and 5 here. That does work. but this has to be kept very low. In fact, that would be 1 or 4, and that would be 1 or 4. So if these were 5s, these would be a 1-4 pair. And actually that doesn't work, because that would be 1-4, this would be 3-6, but these would be meant to add up to 1 more than 5. And they would have to be 3-3, and that's not allowed. So this is not 5. I'm going with this because... No, I'm not. It's assumed the minimum there. I don't have to assume that. These don't have to add up to as much as 5, so that doesn't have to be part of a 1-4 pair if that's a 1. Oh, bother. Okay, what happens if that's a 4? 8, 18, and that's 20. We've got 16 more to go. Well, this can never be 8. But these could add up to as little as 13. This is 1, 2, or 3. I mean, that much we have learnt. It's nothing, but it's true. Oh, these are doing my head in now. If that's 1, 4, this is 3, 6. Then this has to be 4. Because the 3 would add to that to get 1 more than this. So it would add to a 2 there to get that. If this is 2, 3, that's 4, 8. And then that's a 2 again. That's always a 2. Well, I mean, that's something I've found. Doesn't help, but it's nonetheless a truth. This is so crazy. It's a balancing act. It's a plate spinning act with the blues. I haven't thought about the yellows, but I mean, I just don't know what goes into yellow. And even if I sort of care that they add up to 36, I don't know how to use it, or that green adds up to 144. I think I have to fall into those the other way. Now, these are basically consecutive, and they involve a 4. If only that helped. These are from 2, 7, 8, 9. That's not very interesting. This central column, we haven't quite got a 6, 7, 8 triple. If that was a 5, we do. I've looked at that before, and it didn't do anything before, and it's not doing anything now. Okay, if that's a 1, 4 pair. No, this is 4 or 5. Is that doing something in this cell that I haven't seen before? I think I might have just discovered 6 is in one of those two, but I don't think it actually does anything. For 6 to be there in a 25 sum, these would add up to 19. Oh no, there is a way of doing it. In fact, there's 2. 982 or 973. That's no good. Actually, that's quite interesting. These have to add up to 20. If that is 7, 8 or 9, we have a quadruple there, leaving 1, 4, 5 here, which is 10. Then these two would have to add up to 10, making this one 7, 8 or 9, because of what we've put in here now. And that would form a quad of 1, 7, 8, 9, making this specifically 2 or 3. It's almost interesting, anyway. And that's if this was 7, 8, or 9. Now, the alternative is that this is 1. And that's a 7, 8, 9 triple. Now, what happens then? Does something interesting result? from that? No, probably not. Well, sometimes even my perseverance is a bit strained. So maybe I'm just going to have to call this one a fail. That would be so disappointing. It's such an interesting puzzle. And I do think we've got to some of the depths of it now, but having learnt that red adds up to 144, I wanted to be able to get there, and I can't quite do it. Narrowing this down one digit at a time has very little appeal. You know, if I could definitely say that those two added up to 4, well, I'd have something then. Then I could move forward. But I don't think I've got that at all. 7 there. In fact, let's do the maths. The perimeter adds up to 180 minus 2 sets of each of these, which is somewhere between 54, I'm doing the 2 times, and 46. So the perimeter is 180 minus somewhere between 46 and 54. So the perimeter is 134 to 126 to 134. Now for red, the red bits of the perimeter. So these other cells have to add up to an even number that is somewhere between 10 and 18. And we've got 7 in column 2. So these add up to an odd number that is somewhere between 3 and 11. I mean, that's just not enough information to do them. It isn't. I mean, it's not enough. It's not enough. It's frustratingly not enough. Okay, one more shot. If this is a 2-3 pair, that's 4 or 5, and so's that. But this is 4 or 8, so we know which way these go. They're a 5 pair, and that's a 4. And this has to go 6, 7, 8, and that's a 9. So if this is a 2-3 pair, we get a lot of these digits. And where are we getting the 4s then? If that's a 2-3 pair and that's a 4, this is a 4. No, it's not. Hang on. That's a 5, that's a 4. Okay, that was 6, 7, 8. Okay, so we're getting, I think I've done this before, but we're getting 4s in these positions. Not in the blue cells. We're getting 4s in these positions. One of these is a 4, one of these is a 4. One of those is a 4, of course. It doesn't really resolve anything. It's the closest we have to resolving anything. And also, if that was 2-3 and this is 4-8, this is a 7-9 pair. Then we have that 6-7-8-9 quad. And that means something. That means that's 2 or 3. And of course, these two have to add up to 1 more than that. I haven't thought about that in a little while. Oh, 9 can't be here. You see, that is a conclusion I could have reached ages and ages ago. That is quite an interesting one. 9 can't be here because these two add up to 1 more than that. And the other digit here has to be at least a 2. So that would break this. So if 9 can't be there in the column, it has to be here, and that's in blue. And that means that's not a 9. Now, does that... Well, okay, so our blue total now is 18, 20, 21. And the other cells have to take it up by another 15. And if these were 5s, then that breaks it. 18, 20, 21. Yeah, that does break it. Okay, well, this might work. These have to be 4s now. And they add up 10, 20, 29. These two add up to 7. That's 5 or 6. And this is 1 or 2. Those two cells add up to 7. And we've got these 4s here. So that's 3, 6. I'm going with it. I think this is right. This is now a 1, 4 pair. And that's not a 4. And none of these are 4s. So that's 3, 5 or 6. 5, 6 or 7. This can't be a 5. That can't be a 6. That's not a 9. 9 is in one of these cells. 1, 4. Now we've got 3, 6, 1, 4, 5 in this row. Still, these two have to add up to 1 more than that. If they were, or if I misremembered that relationship, I might have. Was it 4 more than that? It was, wasn't it? So this whole thing didn't work at all. It was, I misremembered. I'm going to have to stop. Bother. Oh, bother. Mind you, I still think it was quite interesting that for those to be 5s, that couldn't be 9. That didn't work. That has to be an 8, and that has to be a 5, and that has to be a 1. Well, there might be something that does go wrong with that. Five, 5. Maybe I'm not quite giving up yet. Nearly, but not quite. Do you know what? That doesn't work. I think. Because for these to be 5s, that can't be a 5. It's 3 or 4. And that's 2 or 3. And this has to be an 8. So 9's up here with 2 or 3, making 11 or 12. And this is 4 less, it's 7 or 8. Well, that is the 1, 7, 8, 9 triple, quadruple. And that's a 2, 3 pair. But this now can't be 1. So you've got 5, 5, 8 here, and at least 2 here, 22, 23, 32, and this can't be a 4 to get to 36. So that doesn't work because that can't be a 1 anymore. Right, so those are 4s, and we can do this 3, 6 and reduce that to a 1, 4 pair. I'm still just alive by the skin of my teeth in this puzzle. That can't be a 4. These can't be 4s. And now that can't be 5 and that can't be 6. That's all still true. Now the blues are adding up to 8, 10, 20. These others have to add up to 16. There are ways to make that happen at the moment. I don't see that those have changed now that we made these 4s. That didn't rule things out. Oh, that 4's looking up at this cell. Oh, that's huge. 1 there, 4 there, and we can do the whole thermo suddenly. Well, that has changed things. That has changed things. Now I can place 9 in this box by Sudoku. And that's not a 9. And the only place for 9 in column 2 is there. Four, 5, 9, 7, 8. This digit has become a 1. It's a naked single suddenly. Well, now we can add up the reds. Look at that. these add up to 12. So the perimeter reds I'm allowed then add up to 132. And that means that the blue perimeter digits add up to double the difference between 132 and 180, which is 48. They add up to 24. These ones are worth 10. These ones are worth 14. It's either 9.5 or 8.6. Okay, you remember that for me, that these two add up to 14, because that matters. Yeah, it matters somehow. That can't be a 6 by Sudoku, so what on earth pairs did I have written in here? Well, I don't know, but it can't be 6.4 or 9.1 now. I don't think I used them, whatever it was. Thank goodness. 6.4.9.2.3.4 is looking down at this cell, has been for ages. So we get that as a 1. We're going to get a 4 in one of those positions. 1, 3, 2, 9, 4, 6. We've got 5, 7, 8 to place in the central column. That's not a 4, that's not a 7. 6, 4, 9, 7, 8. Now, that's not a 1. Come on, let's read across the rows. That's where we're getting the joy here. And by joy, I mean a slightly limited form of it. Okay, no, the columns here, or this bit. Still don't know if that's a 1. One of these two is a 1 now. And, oh, hang on. We worked out from red that these two add up to 14. So then we can do the sum in blue. And isn't this a 2? 14, 24, 34. Yes, that's a 2 to make 36. Oh my goodness. So that's 3 or 4. That's definitely 5. Now I can run that up the thermo. Wow, that is a naked 2. That's a 3, that's a 4. Those add up to 4 more than that cell, which is a 1, which is what I suspected at the beginning. And I think we might actually be on the path for a finish here. This has been an extraordinary odyssey. That's a 4, that's a 7. This is just Sudoku now. 5, 6, 4, 2, 3. Unlike Simon, I like it when it comes to Sudoku. 4, 5, 6 down here. Now we got that 9, and these two added up to 14, didn't they? I'm just going to check the maths again. Yes, that's a 5. Okay, and the blues add up to 36. Now the yellows, I almost have enough information to try them now. 3 or 6 there. I probably don't need to. They're probably just going to do the job in the end anyway by Sudoku techniques. That seems to be a 3-6 pair. That's good. So in the top row, I've got an 8-7 pair left to complete. This has become a 3, and that's a 2. This is a 7-4 pair that can be written in. This is an 8-6 pair. That can't be. But this is not a 5, and nor's this. And that's not a... Oh, hang on. That's not a 4 either. That's a 6. And that's an 8. And now I can write in that 8-6 pair. And I can do that pair too. And this digit is a 9. And these are an 8-5 pair that are done. And enough of this is coming together now that I feel we are getting there. This is a 7-8-9 triple at the top. This is a 1-3 pair. 2 and 5 in these cells. That's a 1. This is 7 and 8. I've really blown my brain out on this one. And that's a 2. Now, I have got deadly patterns remaining that are going to be resolved by adding up the yellows. 1, 6, so I was going to have to do that all the time. 16, 21, 22, 28. That has to be an 8 to make the yellows work. Isn't that gorgeous? They now add up to 36. And if you want, you can add up the greens, and they will add up to 144, because that is the deduction that we've achieved by completing the puzzle. There we are. My goodness me. I am going to add up the greens because I'm that obsessed. 18, 28, 38, 48, 56, 60, 68, 71, 80, 91, 100, 113, 120, 129, 131, 137, 144. Exactly as mandated. My goodness, Patrick, that is a monster to me. And I did have to do that holistic maths. Oh, I'm so pleased I finished though. Honestly, the joy of actually cracking through a hard one. I mean, I think I'd announced I'd given up at one point, but I haven't. I've finished. Do join us another day for some more cracking the cryptic, because it's not always this roller coastery, but it is always fun. And we'll see you again another time. Bye for now.